These are the notes for Friday the 15th of January. You can open up your packet and begin taking them. The accumulation function is seemingly pretty simple. However, not always. So we kind of already know that our area under the curve is defined by our definite integral, which is our integral from a to b f of x dx. So let's give this function down here the line f of t equals 2. And we're going to consider this expression, which you can kind of guess what this expression does. It's got a variable on the top. So we're going to be moving along the x-axis. And what we're going to be doing is really just collecting area under the curve. So that when we calculate the integral when x is 0, we know that from the same limit to the same limit, our area is 0. When we put a 1 and we integrate from 0 to 1, what we're doing is finding the area of this 1 by 2 rectangle, so it's 2. Likewise, when we go to 2, we've got the 2 by 2 rectangle, so it's 4. Similarly, when we go to 3, we got 3 by 2 rectangle, 4, we got the 4 by 2 rectangle, etc. And all we're doing is collecting area. As x gets bigger and bigger and bigger, my area grows and grows. So hence we call this the accumulation function. You might get a little confused with why they use f of t, but only so that we don't have the same variable on the top as the one in our function, because that can be kind of confusing. So don't let the variables bother you. It could be from 0 to x, h of q, dq, and we would just move along the q-axis and accumulate area. So now I've got another function. Let's suppose this is the line y equals x, and I am going to again use my accumulation function to evaluate the definite integral. Similarly, same way I did on the last one. If I go from 0 to 0, my area would be 0. If I accumulate from 0 to 1, I now have 1/2 of the base times height, or 1/2 of 1 times 1. When I go to 2, I can either think of it as this area plus this trapezoid that gets accumulated, but I kind of think on this one it's just easier to do 1/2 of 2 times 2, base times height. When I go out to 3, I'd have 1/2 of 3 times 3, or I could take what I already had here and accumulate this trapezoid more. Either is fine, but again, the triangle's easier. So 1/2 of 3 times 3 would be 9/2. If I go out to 4, I'd have 1/2 of 4 times 4, or 8. And I'm just accumulating area as I move along the x-axis. Seems easy. Now what we're going to do is say, well, let's suppose what's on the x-axis is a rate. And I want you to change these f of x's to g's, because that's what the AP exam calls them. And I think we've been using big F as an antiderivative. So I found this sheet online, and I mean, you can certainly use capital F because it's just a name, but we're going to go change all of these capital F's. That would be a G prime. I'm going to change this capital F to a G prime. And right here, and everywhere we see the big F's, we're going to change them to G's. So now I've got a function accumulating the area under the curve of this f of t. So this is t, and this is the graph of f of t. And it says, think of this f of t or f of x as a rate of snowfall. So we're going to consider this a rate. And it's going to be in inches per hour. So my time is going to be in hours. And I'm going to be graphing the rate in inches per hour. So not the snow accumulation, but the rate that it's snowing. That's what my g of x is, my f of t is going to, I'm making a big mess over there. Let me erase that. So maybe if I label it down here, this vertical axis is my f of t, which is going to be given in inches per hour. So notice when I multiply hours times inches per hour, I get inches, which means the area under the curve represents the amount of inches of snow that are accumulating as it snows. So we can kind of think of it as this. At x equals 1, it's snowing at a rate of 3 inches per hour. At x equals 3, it's not snowing. So this is the rate that it's snowing. At x equals 4, we have a negative rate, which means the snow amount is decreasing. So actually what's happening is snow is melting. So let's go over here. And again, I would like you to call this G. And on the side here with these, I always recommend, these are very common AP questions, and usually they define G of X, which is what we're going to do here. And I want you to write this. And before we even answer any questions, they're going to ask you questions about G. They're going to ask you questions about G prime. So let's lay out over here what G prime is. G prime is the derivative of the integral. And remember, when we do the derivative of the integral, the second fundamental theorem of calculus says all we do is get the same function back with a variable replacement. So when we're thinking about G prime of x, that's just f of x. What does that mean? It means that G prime of 1, 2, 3, 4, 5, 6, 7 is actually just f of 7, or the y value, which is -1. G double prime will be the derivative of G prime, which would be f prime of x. So really, if I put this into words, what G is doing is giving me the area under the curve. G prime is actually a point on the curve, and G double prime is the slope, because this is f. So G double prime is f prime, or the slope's there. So if I'm being asked questions about G, it means area under the curve. Anything about G prime means point on the curve. Anything with G double prime means slopes of the curves. So let's go evaluate some. It says complete the chart, and we're doing G of x. G of x is the area under the curve from 0 to x. From 0 to 0, it's 0. From 0 to 1, it's a trapezoid. A trapezoid's area is 1/2 of its height times the sum of its bases. Its bases are 1 and 3. I add them up for a 4. The height is 1. So it would be 1/2 of the height times the sum of its bases, which would give me an area of 2. And put a 2 in there. So what that means is after 1 second, I have accumulated 2 inches of snow. Because when I did that base times height model again, I did hours times inches per hours gives me inches. So this really is going to represent inches of snow after this many hours. So at 2, I could think of this as another geometric figure, but I'm just going to consider it as the 2 I already have plus the area of this one. So it's 2 plus a 1/3, which is going to give me an area of 5 for the whole thing. Means this part's 3, but I've now accumulated 5 inches of snow as the snow continues to fall. Now here, snow is still falling because this rate is positive. It's just falling slower. So it is snowing, it's just snowing slower, but snow is still accumulating. In this hour right here, it's accumulated that triangle's worth of snow. That triangle is 1/2 of its height times its base, which is going to be 1/2 of what? 3 or 1.5. Let's do 3/2. So now that I've accumulated that much more, I'm up at 6.5 inches of snow. Now what happens is my rate is negative, so snow is melting, and I'm going to start removing snow from my accumulation total. So when I go to 4, right here, this is going to be negative, and it's going to remove snow from my accumulating total. It's a 1 by 1, 2, 3, 4 rectangle, so 1/2 of base times height. It's going to be 2, but it's below the x-axis, so it's -2. It's going to drop me down to 4.5 inches of accumulated snow total. This one's also -2, so now I'm going to go down to 2.5 inches of accumulated snow, and then I'm going to go to 6, which is going to add this little triangle. It's a 1 by 1, so I do 1/2 of that. I'm going to be adding another 1/2 of inch of snow, which is 3, and this triangle is a 1/4. I don't want to keep doing the geometry of it. And now what happens at 7, I've got this little triangle going here, which is going to remove 1/4 of an inch of snow because this again is negative, so I'm down to 3 inches of snow. And then last step down here, that would be a -1 because it's a 1 by 1 rectangle below the x-axis. So really what G has given me is the area under the curve. In terms of the snow analogy, it's giving me how much snow has accumulated. So it says let's consider g prime, which is the derivative of f. And remember, what you would expect to happen is the cancellation of the derivative and the integral. And that's exactly what happens. The second fundamental theorem of calculus says you guys are inverses. So all that's going to happen is we're going to get a variable change. So now when it's asking me to find g prime, that's really just f of x or f of t. It's really just points on the graph. So let's go up here and figure it out. G prime of 0 is really just f of 0, which is 0. G prime of 1 is 3. It's just the f value from the second fundamental theorem of calculus. And so these are really easy to do because it's just asking you to give points along the graph. At 2, I'm up at 3. At 3, I'm at 0. At 4, I'm at -4. At 5, back to 0. At 6, I'm up at 1. At 6.5, I'm at 0. And at both 7 and 8, I'm down at -1. So when I did the derivative of the integral, I just got the function back. So again, these are just giving me points on the graph. So now I'm being asked, on what subintervals is G increasing? The one that's accumulating snow. So G is increasing, right? When, let's go back up here. You can kind of think of it as a snow analogy, or you can even look at your chart. It's going up, it's going up, it's going up, it's going up, and now it starts to go down. G is increasing in this whole region right here. Why is that? It's because that's where G prime, which is F, is positive. So I've got an increasing amount from 0 to 3 union. Where else is G increasing? Well, G is increasing where G prime is positive, but G prime is f of x. It's negative here, but then it's positive again. So I'd also say from 5 to 6.5. I hate having to keep scrolling like that. And likewise, it's decreasing everywhere G prime, which is equal to f, is negative. So you're just looking everywhere that graph is below the x-axis. Kind of easy. Where does G, I want to call it G because I want you to get used to it because that's what the College Board likes to call it. So where is G achieving its minimum and its maximum values? It's kind of like the snow. Where's the most snow? When is there the least snow? If you think of it that way, it makes it kind of easy. All right, because G is the one that's accumulating area. You can even look at the chart because we already calculated it. We had the absolute most snow at 3, and at 3 we had 6.5 inches. So we would say that it achieved its maximum at x or t equals 3, and it's its minimum when, and we can even look at the chart because we've already calculated it, but I had the least amount right here at the beginning before it started to snow. So its minimum would be at 0. Now when I'm looking at the concavity, and again change that to G, when it says find the concavity and any inflection points, justify your answer. Well, concavity is about the second derivative. So let's go back up here and see what we're being asked to find. Scrolling, scrolling, scrolling. So when I'm talking about concavity, I'm talking about the second derivative of G. But G double prime is F prime. So I'm looking at the slopes on this graph. The slope is positive, so it's concave up. Slope is 0. Concave down this whole region here. So because the slopes on F are negative, concave up, concave up, concave down, and 0. So when it asks us to find the concavity and any inflection points, we'd say concave up, on, and we'd put all those intervals where my pen, as I traveled along the graph of the graph of F, where I was going uphill. So I'm concave up here, and I don't want to list all those intervals. I'm concave down here, There was no change in concavity at either of these, but right here I'd have an inflection point because I was concave down and then concave up. We're just going to leave that one blank. I think you get it. You won't be asked to graph these. So what I'd like you to do next, the next page says skip, but I want to answer a couple of the questions just for practice, and then I'll tell you what you need to do for the rest of the hour. So again, I don't like calling this big F. I like to call it G. And I on the side always like to put that. My G function is accumulating area from 0 to x under the curve of f. G prime is the derivative of the integral. So when I just dump that in with my second fundamental theorem of calculus, G prime is really just f of x. G double prime is f prime. So let's go answer a couple questions. All right, and again, let's pretend all these are G's. Let's go just do a couple of them there. What is G of 2? G accumulates the area from 0 to 2. It's a quarter circle, radius 2, above the x-axis, and it's positive. So it'll be 1/4 pi times 2 squared. It's just going to be pi. If it was below the x-axis, it would be negative pi. What is G of negative 1? G of negative 1 accumulates the area from 0 to negative 1 under the curve of f. But that's going backwards, so we're going to switch it from negative 1 to 0 under the curve of f. But if we do that, we're going to take the opposite of our answer. So from negative 1 to 0, I have a triangle that's 1 by 2. Its area is a half of that, which is just 1. So this has an area of 1. But because I had to switch the limits, I say it's negative 1. This says find G prime. I'm going to erase that so it's nicer. G prime of 6. What does that mean? G prime of 6 is really f of 6. What's f of 6? 1, 2, 3, 4, 5, 6 down here at negative 1. The f ofs are the dots on the graph. If I'm asked where G is increasing, G is increasing where its derivative, which equals f, is positive. So where is f positive? And you would say from here to here, here to here. That's where G is accumulating area and it's increasing. Where is G decreasing? Anywhere G prime, which is equal to f, is less than 0. So I'd put this interval and this interval. Basically what that means is area is being removed because these are negative from G, so that's where G, which is accumulating area, is decreasing. Maxes and mins, we should be fine. Okay, let's talk a little bit about maybe some concavity. Where are we concave up? Anywhere where G double prime, which is really f prime, is greater than 0. So I'm looking at the slopes of f. I'm looking anywhere where f is going uphill. So G, I feel like F and G alphabet soup here. Hopefully it's making sense to you. G is concave up, where G double prime, which is f prime, is greater than 0. So I'm looking for where it's going uphill. So it'd be concave up here, not here, because that's where f double prime is 0. It'd be concave up from here to here, and that would be it. So it'd be concave up from what? Negative 3 to negative, it's hard for me to read on those dots. That's why this one said skips, but I think you get it. And you don't need to graph them. So what I'd like you to do, in your packet for 4.4, go ahead and take that out. I'm going to give you a few directions on it. For the 4.4 packet, go ahead and find it, and I'm going to find one for myself here. I want you to go to the page that says the accumulation function homework. And you can cross off F. So I want you to do number 1, A through E. You don't have to graph it. But before you start, again, I'd like you to go change all those big F of X's to G's, only to keep it in the notation that College Board uses. And our book, again, uses capital F for an antiderivative, so I think that's a little confusing on here. Then what I want you to do is you've got the big graph, so go take out, Make sure that's open. You have the graph that goes like this, 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 and then there's a little quarter circle and then a dip. And it looks like it kind of goes, I don't know, I'll do my best right through here. And what I want you to do on the side is what I did on those other ones. I want you to write g of x is accumulating area under the curve of f. That means g prime, any questions about g prime are going to actually just be the derivative of this function, and the derivative of the integral is just the function itself. G double prime of x is going to be f prime of x. So again, any questions about g, we're talking about area. Positive if it's above, negative if it's below. Be a little careful, by the way. Like this one, you're going to be able to do getting a trapezoid, but when you're doing this area in here, you're going to have to do a rectangle minus a quarter circle. So when you're asked to figure out what the integral is from 1, 2, 3, 4, 5, 6, 7, from 5 to 7 in there, whatever, got to be a little careful because you're going to have to do a rectangle minus a quarter circle. So be a little careful with that. Any questions about g prime are actually just points on the graph. What is g prime of 0? It's up at 2, so we say it's 0. Any questions about concavity are g double prime means you're looking at the slopes on the f graph, and that should help you out. And again, cross off letter F. There's just 2 of these, so the one on the back, same deal. I would again go change all those capital F's to G's. On the side, I'd lay this out, and you can cross off F as well. You're going to do A through E. I don't think that's going to take you very long. You should finish it in the remaining 25 minutes for sure. I did post the solutions. So the solutions are in Schoology, Unit 4. The entire packet is due on Tuesday. Honestly, all you should really have to finish are a few stray ones. Remember, there was the book work, so that's out there. That assignment is listed in full in Schoology. Maybe you haven't done that page 156, the back of the first page, so that might be something you might want to work on when you finish the 2 accumulation problems. It's just some antiderivatives just to kind of keep that fresh. So page 156, 1 through 15, you might want to keep working on. Whole assignment is due on Friday, on Tuesday, and use your time well, please. The last time I had a sub 5th hour, I was told there's quite a lot of digging around, so please don't do that. I know it's hard not to when it's a Friday and I'm not here and you don't want to work, but when you're juniors and seniors, it's kind of expected that you suck it up and do it. You guys have a good one, and I'll see you later.